question 7 part 2 starts kind of nice. You just need to work out the volume of a sphere. They give you the radius and everything, so you just throw it in the formula and you get that. Make sure your 3 decimal places is okay. Then we go on to part 2. It's not E, it's part 2 of D. And we'll come back to that in a minute because you're going to have to use some information from up there. Okay, so first thing I did is I drew the bit that was cut off because they didn't do that for you. And then I'm going to use one of the only numbers that they give us is 5.4, which is the area of the circular base. So this area here is 5.4. And the only bit of maths I can really do is work out R. So I'll do that. So I work out the radius and it's 1.311. Now at this point, I was like, okay, I've done that. Kind of, so what? So then I remembered, oh, look, it's part 2. There must be something in part 1 that's useful. So I come up here, I put my 1.311 onto my drawing, and then I came up here and I said, oh, the radius of the sphere is 2.7. So that means that this bit up here is 2.7, because that's the radius, if that's the centre. I added my own centre. So this is 2.7, but also this is 2.7. And then I've made myself a right angle triangle. Now, right angle triangles are really powerful. You should make them whenever you can. Looking back at question 4, we made ourselves a right angle triangle, and we're doing the same here. So right angle triangle, 2.7, we've got that. 1.311, and now you can work out this little bit. So that's what we'll do. We'll work out this little bit, and then once we've done that, you're just going to add this 2.7 to our little bit, and we'll be done. So Pythagoras here, you get 2.36. Add on the 2.7, and again, this top bit is 2.7. This is 2.36. So add them up, and you get 5.06 centimeters, which is 51 millimeters. Right, part E. Again, we just spoke about right angle triangles. There are 3 of them in this shape. So that's the first thing. So the first one is E to B to C, the big one. Hopefully that's sticking out here. The shaded one is also a right angle triangle, and BOC is also a right angle triangle. So there's 3 of them, and we're not going to do much else other than look at those. Okay, so our strategy is we've got to work at X. To work at X, we're going to need this side, so OB. To work out OB, we're going to need to know something about this triangle at the bottom here. And the thing we can work out is this angle here. It's the only thing we can work out, and we work that out using the big right angle triangle. So you're pretty stuck for options, really. So if you look at this picture, the only triangle that you have 2 bits of information for, X doesn't count as information, is the 15 and the 30. So the EBC. That's all you can do. You can work out the distance from E to C, and you could do that. It just doesn't lead you anywhere. It's not useful. Although having said that, no, you can't do it. Can't do anything with it. So you could work out this is, I don't know, 40 or whatever, but then there's no way of saying, well, how much of it's this and how much of it is this. So it's not that useful. This angle though is key. And it's key because it's also an angle in the OBC triangle. Okay, so down here. So this is the 1530 triangle, the EBC, and you do some tan on it and you get 26.565. Then the OBC, because we now know what this angle is, you can work out this side here. That's just trigonometry. Make sure you label it properly. A there, C at the bottom. Hang on, yeah, C at the bottom. So yeah, you put that all in. Make sure you use the whole angle, the 26.5. Make sure you use the whole thing, and then you get 13.4. Blah 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 blah. That's O to B, and now you can just do Pythagoras. Now you know this one. So you do some Pythagoras on that little skinny shaded one. 13.4 is what I've written there, but again, use all of that in your calculator. Use the answer button or store it, and you get exactly 3√5. And when you get an exact number like that, you know you've probably gone right.